We have a pleasure today of chatting with Chris Brooks from University of Michigan. So Chris, you're involved in a range of research areas that are very timely, very relevant across higher education as a whole. You look at things from MOOCs to machine learning to video annotation, a range of other topics. So can you give us an overview in terms of what are you doing with educational data that might be relevant for this MOOC?
One of my key interests is in how people interact with different forms of educational technology and educational resources. And so I use machine learning to analyze their interactions and try and build predictive models. Another thing I try and do is I look at using clustering mechanisms to try and understand what kinds of students exist in the class and the commonalities or the differences between different groups of students.
So with that kind of work, obviously you're trying to cluster and you're trying to group students, you're trying to identify some of the differences that exist between the learners. By being able to do that, what kind of insight are you expecting from that? Or what is it that you're doing through that process that enables you to do what differently?
One of the most interesting insights that we've gained so far was looking at second-year STEM courses. And we were interested in the flipped classroom and how lecture capture changed students' behaviors and how it related to their achievement. And so one of the techniques we used was k-means clustering, and we clustered people's behavior viewing lecture capture over the course of a semester. And from this, 5 interesting different clusters came out, and one of those, the people who regularly use lecture capture technology, was related to their, or correlated well with their academic achievement, or an increased academic achievement.
And so if you get an insight like that, so you've got a group of students that are taking these video lectures, or viewing them, and you've got some that are regularly engaging with video lectures. I'm sure you have a large cluster that are engaging the day before a big test or an exam to catch up. Knowing these kinds of different patterns of learner participation in video viewing habits, what does that enable you to do differently? Or how would you advise an instructor to think differently?
So the most interesting part of that is it leads itself towards a causal model. So is the lecture capture solution, is that actually helping students learn, or is it just that people who do learn well and do get high marks, do they always regularly integrate this with their academic study? And what we did was we looked at how people's incoming grades differed between these 5 groups, and these 5 groups actually didn't differ statistically with their incoming grade, yet their one group did differ at the end of the course by up to 10%. And so that suggests a causal model and suggests that lecture capture technology might be helping. Another thing we did was we took that model and we replicated on another year of the course. We applied that scientific process from our data-driven. So we've been able to use data to build a theory and then validate that theory through repeated application.
What kinds of tools and technologies do you use in your analytics work?
Most of our analytics work deals with log file analysis, and so something like Python to do the basic data cleaning is really important. And then we use a tool from New Zealand called Weka to do the actual machine learning and do the clustering using k-means.
So I'm a teacher in university or college, and now I'm trying to gain, so I understand some of the analysis work that you're doing, some of the insight that you're gaining. What does that do to me? I mean, what can I do differently now based on, or how does your work apply to me?
I think the most important thing is to look at this model and say, well, does my cohort of students, is it similar to the one that we used? And we used a chemistry class, we validated it on another chemistry class, and we looked at a biomolecules class. So these were all second-year STEM disciplines. And so if you teach in second-year STEM disciplines, you might find that your class is actually very similar. And so then you can change your pedagogical approach, but you can also change your tutoring, and you can start to do things like recommend to students and watch how many lectures they're watching and really try and encourage them to continue that positive behavior.
All right, perfect. Thanks.